Welcome to the second part of solution video. In this video, we are going to discuss problem 8 through problem 14. First, problem 8. This problem is similar to problem 9, the next one. So in order to compute the probability that Andy wins Billy, there are three cases. Case 1 is when Andy shows rock and Billy shows scissor. So this is the case. The probability for this case is the probability for Andy shows rock is 0.2, and for Billy to show scissor is 0.1. So altogether, it's 0.02. So that's case 1. Case 2, so when Andy shows paper and Billy shows rock. And the probability would be 0.3 times 0.5. That's the probability for Andy to show paper, 0.3, Billy to show rock is 0.2, so it's 0.15. Case 3, so when Andy shows scissors and Billy shows paper, so that probability would be 0.5 times 0.4, so it's 0.2. So if we add all these three probability together, three cases together, then we would get 0.02 plus 0.15 plus 0.2. That's 0.37. So the answer is B for problem 8. Problem 9. We use the similar method as in problem 7. So what is the probability that the red ball is tossed into a higher number bin than the green ball? So there are two cases. Case 1, that the red ball is tossed in number 2 bin. So if the red ball is tossed in number 1 bin, it's impossible for the red ball to be tossed in higher number than the green one. It's impossible. If the red ball is tossed in number 2, that probability would be 2/6. And so the green ball is tossed in the ball number 1. So the probability for that case would be 2/6. That's the probability for the red ball to be tossed in the second bin, times 1/6. That's the probability for the green ball to be tossed in number 1 bin. So this would be 1/18. Case 2. So red ball is tossed in number 3 bin, and the green ball is not tossed in number 3 bin. The probability for this case is the red ball tossed in number 3 bin would be 3/6. And the green ball is not tossed in number 3 bin would be 1 minus 3/6. So this would be equal to 1/4. So the total probability, would be equal to 1/18 plus 1/4. So 36, 2/36, 9/36. So that will be 11/36. So the answer is B for problem 9. Problem 10. How many different real numbers satisfy the equation x plus 10, y minus x equals 1? Let's think about it. The following question. So when a to the power b is equal to 1, there are three cases. Case 1, if a is equal to 1 and b is any real number, Case 2, if b is equal to 0, a is positive. So in particular, a is not allowed to be 0 when b is equal to 0, because 0 to the 0's power does not make sense. And there's a case 3. If a is equal to -1, b is a even integer. So that's the rule. That's all the possibilities when a to the b's power is equal to 1. So let's apply it to our particular problem to see if all the 3 cases will be feasible. So case 1 will happen when x plus 1, number 1, x plus 1 is equal to 1. So in that case, x is equal to -9. And the quick check shows that this is indeed the solution, one of the solution. Case 2, 1 minus x is equal to 1. That means x is equal to 1. And we will check when x is equal to 1, x plus 10 is a positive number. So that gives another solution. Case 3, we let x plus 10 to be -1. Then x would be equal to -11. And 1 minus x would have been equal to 12, which is a even integer. And we can check directly. This gives us the third answer. So altogether, this equation has 3 answers. So the answer is D. In this case, in problem 11, so how to compute the chord QE? So there are many ways to do it. The best way is to use similar triangles. Let me mark the point here, the midpoint of DA, to be capital F. And I will draw a line from E to F. So such a line would be a diameter of the circle. And since EF is the diameter of the circle, then the triangle EFQ is a right triangle, because the inscribed angle is towards the diameter, so this has to be degree 90. Okay, so then we have the following observation. Since the angle here, FEA, and the angle EAB is an alternate angles, so these 2 angles are the same. As a result, triangle EFQ, so there's a Q here, this is the Q, is similar to triangle AEB. So if we want to compute QE, so QE over AB would be equal to EF over AE by the properties of similar triangles. And then QE would be equal to EF over AE times AB. EF is equal to 10 by our assumption, because the side length of the square is 10. So we have this is equal to 10. AB is equal to 10 as well. So we need to compute AE. And we use Pythagorean theorem here. AB is 10, EB is 5. So AE is equal to square root 10 square plus 5 square. So if we factor out 5 square, then it would be 2 square plus 1 square root. That will give you 5 times square root 5. So AE is actually 5 square root 5. And this would be equal to 100 divided by 5 square root 5. And then this would be equal to 20 over square root 5. but we can further simplify it by multiple square root 5 on both numerator and the denominator, and we would get 20 square root 5 over 5, which will give you 4 square root 5. So the correct answer is D for this problem. There's another way to do the job by mark O as the center of the circle, and we can draw OQ, and we draw a perpendicular line and K, so we can prove triangle OEK is similar to triangle EAB, and we can get the same result. Problem 12. So first, Abel, Brandon, and Edward must lie, because if any of their statements were true, then at least one of the Kevin or Dory would speak the truth. So that would contradict to the assumption that only one kid told the truth. Next, let's assume that Calvin spoke the truth. When Calvin spoke the truth, Dory must lie. And that means when Dory say not me, then the Dory must broke the pot. But then Brandon would speak the truth. So that's impossible. So the only choice would be Dory spoke the truth. Spoke the truth. And so then Calvin said it's not me, it must be him. So the correct answer is C, Calvin. Calvin broke the flower pot. Problem 13. Triangle ABC has side lengths 3, 4, 5. Apparently, this would be a right triangle. That's the first observation. Let me draw a picture. 3, 4, 5, which is a right triangle. And the question is, find the probability of the point that has at least distance not less than 1 to the vertices. So suppose at each vertices, I draw an arc length with radius 1. So the question became that we need to find the percentage of the area of the yellow region towards the total area. So first, the area of the triangle is half times 3 times 4, which is equal to 6. So next, we would like to compute the sum of the area of these 3 sectors. For the sectors over the right angle, it's easy because it's a quarter of the disk. How to compute the area of this sector plus the area of that sector? What we can do is we just draw the following picture. We draw a rectangle, and so then we get the green triangle is congruent to the blue one. And by symmetry, we would know that the area here would be the same as area here. So therefore, if you paste the sector here to this place, then we would get a quarter of the circle. So the total area of 2/4 of circle will be half of the area of the unit circle, which is half times pi. Okay. So the area of the yellow region would be half times, it would be 6 minus half of pi. So what is the probability? Will be 6 minus half pi divided by 12. It will be 1 minus pi over 12. And that is, the answer is D for problem 13. Problem 14 is an interesting question which tests us how to make smart use of the corresponding angles and the alternating angles. What we can do is we can draw, first we will draw a line parallel to L1 such that we know that the angle, so suppose this is K. So we know that triangle ACK would be an alternate angle with this 40 degrees. So since the green line is parallel to L1, so triangle angle ACK is equal to 40. Next, we are going to compute angle KCD. We cannot do it directly. What we can do is we draw another line starting from D, which is parallel to L1 again. And so suppose this is K, this is L. So what we can do is we know that angle LDB would be that alternate angle with DB, with the DBL1, DBL2. So that's going to be equal to 30 degrees. So this angle is 30 degrees. So remember the total angle CDB would be 50. So that will give us the angle here would be of 20 degrees. So since the red line is parallel to the green line, we concluded that angle KCD would be equal to 20 degrees as well. So therefore, the angle C would be ACK plus KCD. That's going to be equal to 40 plus 20 equal to 60 degrees. So the correct answer is D.